recycling is an important thing in any process flow sheet. Today let us see how to add a recycle tab in HYSYS and how to handle that so that we can convert the flow sheet with recycle. We have ammonia loop case study in front of us. Let's say ammonia is being produced by means of reacting nitrogen and hydrogen. The feed contains nitrogen, hydrogen, argon, and some part of methane, some amount of methane. It enters the reactor at 77 degree Fahrenheit and 200 atmosphere. Reactor is modeled as an equilibrium reactor, so we will have to add an equilibrium reaction and a reactor. The reactor operates at 200 atmosphere and 500 degrees Celsius. The outlet of the reactors are mixed to form a mixture which is further cooled and the pressure is reduced so that we get a conversion from vapor to liquid, and then the liquid which contains largely ammonia is separated and the vapor which is unreacted is recycled back after compressing. So let us see how to simulate that in HYSYS with the help of recycle. Now see, we already have generated the compounds, and the feed which is according to the the requirement is already been added. The compositions are also as per the requirement, as per the given data. And if you go to properties and reaction, the reaction is already added where nitrogen, hydrogen, ammonia is added. No other compound are added as they are inerts, and the approach is made to be 0, and the default way of calculating equilibrium constant is based on the Gibbs free energy which is available in the HYSYS. So this also has been, the reaction also is properly fed. Let us go back to the simulation. This is the feed which we already have. We take an equilibrium reactor which is available in the columns. We take the equilibrium reactor and the feed enters. Let's say this is V out, L out, and Q reactor, or let's say QR, and let us add the reaction set part. The reaction is added. The reaction takes place at 500 degrees Celsius, so we have to add the temperature which is 500 Celsius, and your reaction is done. And we can see that the outlet composition is having go to design and parameter. Let us see what the result. Okay, so we can see that the outlet product contains some amount of ammonia, and this ammonia needs to be separated. So first we'll as per the data we mix both vapor and liquid. The outlet of this is then cooled to 200 to 28 minus 28 Fahrenheit. So let us mix out, cooler out, and let's say energy is QC, and the temperature is minus 28 Fahrenheit, and the pressure given is 2000 psi. So we have got some amount of a liquid which is generated. We can see that this mixture outlet is this almost is a vapor which is added, and then you have some amount of liquid here. So this liquid needs to be separated. So for that we take a separator, separating column, we add the stream. There is cooler out, unreacted gases you may say, and this is ammonia. And since the pressure drop is already taken place here, we don't need to do anything. This works as a almost a drum which separates liquid and vapor, and you can see that the ammonia content is 92%. So now this needs to be recycled, but before it is recycled we need to purge some portion so that the inerts like nitrogen and argon and methane, that doesn't get built up. So let us take a T. This T will have the input as your unreacted gases. One is recycled gases and other is purge. And we go to parameter and we say that since it is said that 0.04 fraction is purge, so we'll write here 0.04. So 96% is sent to recycle. So this is then taken to a compressor. See, this is then compressed to 200 atmosphere, which is equivalent to the pressure of the reactor. So let's take this as recycled gases R1, let's say, and let's say Q cup, and we have to decide device pressure, which is 200 atmosphere. So this will then be this is recycled back. Now we can't directly attach this to the reactor. If you do that, just see, if you do that, the entire thing would be unconverted. So we can't do that. We have to use a special recycle tab. It basically is nothing but a TS stream. So we take this as R1 and take this as recycle. Now just see that this recycle stream is right now defined same as that of R1, and you can just see that so this can be changed. Now this recycle can be directly attached to the reactor, and you can just see that the entire flow sheet is converged, and there may be some changes in the composition of the product. So we can see that there are some changes in the composition because of the addition of the recycle stream, but then that is because of the addition of the new stream. Now if I go further into the recycle stream, you can just see that these are the sensitivities. Sensitivities would talk about the will make sure that the convergence is proper. Now if you want to say that I want the temperature to be very sensitive, and this basically is the comparison of the temperature of stream R1, which is say for example right now 4.715, and this which is 4.719. Now say for example I'll make it further 0.1 and see it is not converging, right? So you can can just see that it's not solving. But then the moment I'll make it to, say for example, 0.5, it is converged. Now for 0.5, the values which I am getting is 4.893 and this is 4.89, so it has been, the accuracy has been increased. Same way you can play with the, you know, pressure, flow, composition, wherever you feel that this is more important property for me, you can decrease the sensitivity of that. And this is how you can take care of a recycle tab. As such, when you want to recycle in a single loop, you can put a recycle tab over this or this or this. Any of the stream you can use as a recycle tab. So similar processes you can solve with the help of HYSYS, which involves model balance with RECYLE.